Hello students. Today I will discuss some examples of gradient and also the definitions of divergence and the examples of divergence. This note is already uploaded in the LPU live, and so I'm discussing this example. The example is find the equation of tangent plane to the surface, this one, 2x z square minus 3xy minus 4x equal to 7 at the point 1 minus 1 2. So this is a scalar field because there is no I, no j, no k. So this simply an equation is given in the form of xyz. So it is a scalar field. So now we need to find out, so what is scalar field? Scalar field is nothing but a level surface. There is a surface in a three-dimensional space. So what is the tangent plane at this point? That is tangent plane of the surface at this point. This is the required question. So now before starting this problem, you have to remember this equation: r minus r0 dot n equal to 0. Okay, just simply step by step remember this one. This formula is nothing but a tangent plane formula, and where this r is any arbitrary vector, that is we can just consider r as xi plus yj plus zk. So any arbitrary vector r can be considered like this: xi plus yj plus zk. And what is r0? R0 is nothing but this point 1 minus 1 2. That is where the point is already given in the question. Okay, so the vector, corresponding vector for this point, what is the point? 1i minus 1 into j plus 2k. So obviously r0 can be represented by this I minus j plus 2k, this one. And what is n? N is the normal vector, normal to the surface. So what is the n is nothing but, so we know that normal vector, it can be obtained by the gradient. So gradient of this surface, if I find the gradient, if I just obtain the gradient of this surface, we know that gradient is nothing but the normal. So how can you do this? You just need to remember this formula for this is a tangent plane formula. And now I'm starting the problem. First find grad phi, that is grad of the surface. The surface is already given. Find grad of the surface, and this is the grad. That is 2z square minus 3yi minus 3xj and whatever. Now we put this point, the given point 1 minus 1 2 into this grad. So we are getting this vector 7i minus 3j plus 8k, this one. So what is our normal vector n? So to obtain this n, first find the grad of this scalar surface or scalar field. This is the grad. Put the point whatever given, this is 1 minus 1 2 into this grad, and this point gives you the normal vector n. So this is n. Now already we know what is r. R is nothing but this arbitrary vector xi plus yj plus zk. And what is r0? R0 is I minus j plus 2k, that is this point, the given point. Okay, now just put these values into into the formula. So r equal to xi plus yj plus zk. R0 is this point, that is I minus j plus 2k, and we already have n, that is after finding this gradient. Now put this formula and you will get this surface, that is this is the tangent plane for this surface at the point. So this is the required answer. Now my second topic is directional derivative. Now the formula of directional derivative is obtained as grad phi dot a by mod of a. That is, directional derivative is suppose phi, this is a scalar field. The scalar field is given phi xyz equal to c. It is a scalar field. So now find the directional derivative of phi in the direction of a. So directional derivative, so just look at this look at this name, directional derivative. That is the derivative which has some direction. So obviously it becomes, so directional derivative, we have a direction. A direction is given and the direction is a vector. So the question will be like this: directional derivative of phi. We are required to find out the directional derivative of phi in the direction of some vector a. So just look at this example. Find the directional derivative of phi equal to this at 1 minus 2 1 in the direction of 2i minus j minus 2k. So a direction is given and the direction is a vector, and this vector value is given, and we need to find out the directional derivative of phi. A scalar field is given, a point is given, and a direction is given in the question, and you just need to apply this formula. First find out grad phi, and we know the value of a, that is value of a is this, value of a is nothing but the direction which is given in the question. Okay, and we know what is mod a. Mod is nothing but the value of this vector, the mod value of this vector, absolute value of this vector. So now come to this question. The step one is find grad phi. First find grad phi. This is simply grad phi. Now put the point what is given, that is the 1 minus to 1. So first find grad phi and then put the point, the given point. So at 1 minus 2 1, after putting this point into this equation, we have 8i minus j minus 10k. And now just simply apply this formula, grad phi dot a by a bar. So what is a vector? There is a direction vector. Direction vector is 2i minus j minus 2k. Just find, so find this value. This is nothing but the unit vector corresponding to a. So the value of a is this, which is given in the question, divided by mod a. Mod a is nothing but the absolute value of this vector. So it is 2 square plus 1 square plus 2 square. And we have this vector. Now just put it into this formula. We know what is the value of grad phi. Grad phi value at 0.1 minus 2 minus 1 is this one. And a by mod a, the value is this one. Just find the dot product and you will get this answer. So this is a required answer for directional derivative. Another question may also there will be in the examination. The examination will be in the examination the question may be like this: in which direction the directional derivative of the scalar field is maximum. So maximum value of the directional derivative. Okay, maximum value of the directional derivative is nothing but the grad phi. So grad phi, the directional derivative is maximum in the direction of grad phi. Remember this. Directional derivative is maximum in the direction of grad phi. So we already have grad phi. What is grad phi? 8i minus j minus 10k. So the directional derivative is maximum in this direction. Okay, and what is the value of this directional derivative? The value of this directional derivative is nothing but the absolute value of grad phi, that is mod of grad phi. Okay, so if the question is like this, find the maximum value of the directional derivative. So maximum value of the directional derivative is nothing but this mod of grad phi. And which direction the value is maximum? Grad phi direction, that is 8i minus j minus 10k direction, the value is maximum.